Okay, special angles. Now don't panic because I don't expect you to memorize all of this. We'll be figuring out which one is which from the unit circle. For the moment, what I just want you to remember is for sine and cos, the possible values are 1 over 2, root 2 on 2, and root 3 on 2. And for tan, it's 1 on root 3, 1, and root 3. Those are the possible values that we're going to be looking for. Now, if you haven't seen this before and you're curious about how we know these things, I'll just briefly go over this. I won't go into too much detail, but the ones for 30 and 60 degrees, you get them by making an equilateral triangle, cutting it in half, and then focusing on one of the right angle triangles left. Just apply SOHCAHTOA and Pythagoras' theorem, and you will get these facts out of that. And for the 45 degrees, you get that from an isosceles right angle triangle. So where that side's the same as that side. Again, applying SOHCAHTOA and Pythagoras' theorem, you can get those facts out of it. So this is what you need to know. For sine and cos, the possible values are a half, root 2 on 2, root 3 on 2, and for tan, it's 1 on root 3, 1, and root 3. Now, a half is 0.5. And root 2 on 2 is approximately 0.7, and root 3 on 2 is approximately 0.9. Now, you don't need to memorize this. I just want you to get an idea that this is small, medium, and large. Now, for the tan values, just think of this as being like, well, 2 squared is 4, so this is going to be a bit less than 2. It's like 1.7, but all you really need to know is that this is bigger than 1. And since this is 1 over root 3, this one is going to be less than 1. So that's really all you need to know. Small, medium, large. This one's smaller than 1. This one's equal to 1. This one's bigger than 1. Now, the way that I remember which one is which, like which one is cos 30, which one is cos 60, etc., is by just picturing the unit circle. And I'm going to be using the definitions of sine, cos, and tan that I defined in my previous video. So check that out if you haven't watched that already. So, for example, if I want to know cos of 30 degrees, that's this angle on the unit circle, I think, what is the x-coordinate of that point? And I can see that it's the largest of these three, like it's almost 0.9. So cos of 30 is going to be the largest of the three possibilities, which was root 3 on 2. Let's do one in radians. Let's go. Sine pi on 4. Now, you can think of that as 180 degrees divided by 4, so that would be 45. Or you can even think of it like pi is over here, and then half of that would be there, and then halved again would give you a quarter of that, so that would be that one. So what is the y-coordinate of that point? You can see that it's the medium one out of these three. It's about 0.7, so that one's going to be the medium one of the three possibilities. So that's root 2 on 2. Let's say we want to work out cos pi on 3. So you can convert that into degrees. You can go, okay, that's 180 degrees divided by 3, so that's 60, so that's that one. Or you can even like visualize pi is this much, and then if I cut that into thirds, it's like that's 1/3 of it. So we're talking about this point here, and cos is the x-coordinate, and you can see that that's the smallest x-coordinate out of these three. That's the smallest one, so that's going to be a half. Now, you can also, if it makes it easier for you to remember that it goes small, medium, large, you can think of this as being root 1 on 2. So then the pattern is root 1 on 2, root 2 on 2, root 3 on 2. Don't write that in a test. You'd want to simplify that down to 1 over 2. Let me do one more of these. Let's say we want to work out sine pi on 6. Now you can do that as like 180 degrees divided by 6 is 30. So we're looking for sine 30 degrees. That's this angle here. And sine is the y-coordinate, which you can see the y-coordinate at this point is the smallest of these three. So that's going to be the 1 over 2. Now let's move on to tan. So let's say we want to work out tan pi over 6. Now remember that's tan 30 degrees, which is this angle here. And tan is the y-coordinate where you extend this line until it hits this one. So we're interested in the y-coordinate here. You can see that it's less than 1, like 1 is up here. So that's going to be one of the three possibilities for tan that's less than 1. So that was 1 on root 3. If we want tan pi on 4, which is tan of 45 degrees, that's going to be this one. And you can see the y-coordinate there is 1, exactly 1. If we want to do tan pi over 3, that's the same as tan 60 degrees, which is this angle. And you can see that's a very large y-coordinate here. That's bigger than 1. So that's going to be the root 3. So you really just need to remember that these are the three possibilities for tan, for the special angles. And this one's less than 1, this one's equal to 1, this one's bigger than 1. Let's move on to angles outside of this quadrant. So 2 pi on 3, where is that in the diagram? You can think of that as pi on 3 being 60 degrees, and then it's twice as much as that, so it's 120, which is here. Or you can even think of like pi is out to here, and we want 2/3 of that, which, like, if you cut that into thirds, it's that bit there. So that's that angle. And we're interested in cos, which is the x-coordinate of that point. And you can see that it's about -1/2. So out of the three possibilities, it's going to be -1/2. Let's try sine of negative pi on 4. So remember, pi on 4 is 45 degrees. And if we're talking about a negative angle, then we're talking about going this way. So negative pi on 4 is out here. And sine is the y-coordinate of that angle, which out of the possible special angles in this quadrant, like -30 would be there, -60 would be there, it's the middle one, the medium value out of those three. So that's going to be the middle of the three possible values for sine, which was 1 on 2, root 2 on 2, and root 3 on 2. So that one's going to be root 2 on 2, the middle one. Oh, and it's negative, because the y-coordinate here is negative since we're below the x-axis. So that's negative root 2 on 2. What about tan of 5 pi on 6? I would think of the 5 on 6 as being 1 minus a sixth. So 5 pi on 6 is pi minus pi on 6. Or you can convert that into degrees and think of it as 180 minus 30. So that's going to be right there. And if we're interested in tan, then we want to extend that line until it hits this line, like that. So we're interested in the y-coordinate at this point. You can see that it's negative and that its magnitude is less than 1, like here's -1 down here. So it's going to be negative, and out of the three possible values for tan, it's the smallest one, the one that's less than 1, which is 1 on root 3. Now we can also think about the sine, cos, and tan of the four sort of extreme points, or you can think of them as the four multiples of 90 degrees. So pi on 2 is 90, so we're thinking of -90. Remember, negative angles go around this way. So we're talking about that point there. And sine is the y-coordinate. So what's the y-coordinate at that point? That would be -1. So sine negative pi on 2 equals -1, exactly. Of course, you won't always have a nice computer-generated neat diagram to work from, so I thought I'd do some by freehand drawing to show you how that would work. Let's say we want to work out sine of 2 pi on 3. As usual, pause the video if you want some time to think and see if you can work it out for yourself. So what I would do is draw the unit circle. Doesn't have to be too accurate. And 2 pi on 3, where is that on the diagram? it's 2/3 of pi, which is here, so it's going to be like that. Or you can convert it to degrees, which is 120. So that's there. Sine is the y-coordinate at that point. You can see that it's quite high, like it's almost up to 1, so that's going to be the largest of the 3 possible values for sine. So that is going to equal √3 on 2, and you can see that it's positive as well. Let's say we want to work out tan of pi. Let's draw the unit circle. Where is pi on that diagram? Over here. So we are interested in the slope of this line. So you can see there's no rise to that line, it's all run. So the slope of that is 0. So tan pi just equals 0. Let's say we want to work out cos negative pi on 2. That's the same thing as cos of negative 90 degrees, if you want to convert that into degrees. So let's draw the unit circle. Negative 90 is down that way. And then cos is the x-coordinate. So what's the x-coordinate at that point? It is actually just 0. So cos negative pi on 2 is 0. What if we want to work out sine of 7 pi on 6? Now, I would think of that as like 7 on 6 is 1 plus 1 on 6. So we're interested in an angle of pi plus pi on 6, with pi on 6 being 30 degrees, if you want to convert it into degrees. So pi plus a pi on 6 is that angle out there. And we're interested in the y-coordinate at that point. You can see that it's negative because we're below the x-axis, and it looks like about negative a half. So yeah, that is exactly negative a half. Let's find tan of negative pi on 3, which, if you want to think of it in terms of degrees, is tan of negative 60. So where is that on the unit circle? That's going to be roughly there. Doesn't have to be too accurate. Just make it, bigger than 30 and bigger than 45. So for tan, you want to draw in this line and then extend this line until it hits there. And we're interested in the y-coordinate at that point, which you can see is like bigger than negative 1 being there. So, I mean, like it's negative, it's a large negative number. So remember the 3 possibilities for tan: 1 on √3, 1, and √3. √3 is the biggest one, bigger than 1. So that's going to be negative √3. And I just wanted to warn you about ones like tan pi on 2. So on the unit circle, pi on 2 is the same as 90 degrees. So we're talking about that angle there. And if you try to work out the tan of that, it's actually undefined because we're talking about the slope of that line, and it's a vertical line, so it actually doesn't really have a defined slope. If you tried to extend this line until it hits this line, it would never hit it. So we just say that tan pi on 2 is undefined. I want to show you how to use the calculator to verify these things in case you want some more practice. So let's say we want to work out something like cos 150 degrees. So we draw a little unit circle. 150 is over here. You can see that the x-coordinate there is negative, and it's quite large, like it's almost at negative 1. So we might guess that that's negative √3 on 2. Now, if you're not sure about that and you want to verify it, all you can do is go to your calculator, type in cos 150, and then that tells you negative 0.866, okay? So if you are not sure whether that's √3 on 2 or not, you can type in √3 on 2 and say, yeah, it's 0.866. So that's correct. Now, so that's in degrees. I've currently got my calculator in degrees mode. If you can see that little D there, that means that it's in degrees. If you want to work in radians, you can switch your calculator into radians mode. On this model, I have to hit the setup thing, so shift setup, and then 4 is radians, so I hit 4. And now there's a little R there. I don't know how well you can see that. But there you go. So now it's in radians mode. If I wanted to do something like let's say I want tan of negative pi on 6. So I draw my little unit circle. I go pi on 6 is 30 degrees, so we want something like that. Tan of that means we extend that until it hits there. I can see that the y-coordinate there is negative, and it's quite small, like it's less than, well, greater than negative 1. Its magnitude is less than 1, so I would guess that that's negative 1 over root 3. So the smallest of the possible values for tan. So if I want to check that on my calculator, I type in tan negative pi over 6, and that is negative 0.577. So is that the same as 1 on root 3? Let's find out. 1 over root 3, 0.577. So yeah, that one is correct. So you can do as many of those as you like. Try to figure it out. Check your answer on your calculator. So the methods that I've shown you in this video may be quite confusing at first, but once you get used to them, they really are the easiest way to work out sine, cos, and tan of special angles. Now in the next video, I'm going to be talking about solving trig equations. And this is where the techniques that Dr. Hoffman taught me really excel. So definitely check that one out. And if you like this video, then be sure to give it a thumbs up. And if anything still confuses you, then leave me a comment below.